So, Mike, you've shown us a lot of stuff here, a lot of posters, we've been to a lot of rooms. If you had to pick the coolest thing, in your opinion, that's being worked on here now, what would it be?
It'd be the solid state transformer in front of us here. So this is a revolutionary transformer. It's totally solid state, bi-directional. It allows for dynamic control of a distribution circuit. The transformer just picked, I think, top 10 emerging technologies by MIT this year. It's really cool. It can take DC in directly, take DC to AC, AC to DC, bi-directional flow, which standard transformer like in the back there, is dumb, you know. It can only go from high to low, and it just steps down voltage. This thing is going to be dynamic and be able to balance a microgrid with the transformer.
So presumably when everybody has an electric vehicle and comes home at 6 o'clock after work and plugs in, if you have a solid state transformer, you're not going to bring the neighborhood down like you might today.
Right, and the nice thing too is you'd be able to balance the whole neighborhood.
Yeah.
The whole neighborhood could be balanced, and this is the key component to having a functional microgrid, plug and play, the next technology of a microgrid. You don't need centralized generation of electricity. You can have renewables on site, you can have small scale generation on site. Electric cars plug in and they can either take load, or depending on the system where it's at, they could pull some of your battery power to support the microgrid. So this is one of the key pieces of the future microgrid. Centennial is a really cool research facility because what they do is they want to put the university research in here, but also above here you have industry partners that have office space.
Yeah.
So they put the industry with office space along with the university all together, so it works in a really cool research environment.
I like that. That's very clever.
It's pretty cool. I mean, you have ABB, I believe, is here on campus. Siemens is moving to campus. It's a good way for the students to get industry experience. It's a good way for us to get a huge lab with cutting-edge smart grid technology to be involved in that. It's the FID, fault isolation device. This is basically like a very smart circuit breaker. And this is going to be the protection, the future protection for the microgrid. So you have these spaced out communicating with SST. This thing will be able to instantaneously island the microgrid for maybe central generation and support it.
Yeah.
So this is just like a super fast, super smart, high voltage circuit breaker that can go on and off at any time. This is our Green Bus platform that we've been developing. It's an open source SCADA system.
Okay.
And so this is a representation of the lab here in a one-line diagram. So this is the actual lab you'll see downstairs with the transformers, circuit breakers, protection. There's termination cabinets around the room, and these are actually microgrid. So this allows us to do distribution level microgrid in the lab.
So this is a schematic of the power architecture of the lab?
Of the lab.
Okay.
There's the EV charger outside.
Oh, okay.
So actually, that's the data we're reading from it right now.
So the charger that the Volt was parked up against wasn't delivering power, but the one on the wall behind it was.
Okay.
And that would show up here?
That would show up. One of the issues that you have with any of this new smart grid stuff is it's not quite all ironed out. You'll find some of these chargers coming from different manufacturers don't have communication ports on them, that type of deal. So the one you were charging off of actually did not have communication support.
Really?
Yeah.
That's surprising.
It had a proprietary protocol that you can't just get into easily. So you'd have to backwrite a whole piece of software just to be able to talk to it. Eaton does their Modbus, so we were able to get into Eaton pretty easily with Modbus. So that is going to be one of the biggest challenges of the smart grid, is actually getting everything to communicate.